Year 5, you are ready for your next math skills lesson. Thank you very much for joining me. We have got 3 different activities that we are going to work through today. And to help us with those activities, we've got a list of key vocabulary. Yes, back to that list. So you can read these words. We've got partition, part, whole, thousands, hundreds, tens, ones, which we have all referred to many of times, multiple, many of the same, inverse, thinking carefully about those opposites, the half and doubling, really key facts that I really like to refer to throughout, equal, unequal, and then thinking about multiple and the nearest, because we're going to be doing a little bit of rounding. Okay, so activity 1, it's our very, very familiar part whole model. I like to work with this activity because it gets your brain working, it gets you really thinking about how numbers can be partitioned into many different ways. So, to get us started, you're going to help me with this side, then I'm going to leave you alone so you can do this side on your own, and we'll come back and we'll check it. Yeah? So let's get going. 7,470 and 50. What do we spot? We spot a likeness between 70 and 50. We combine those together, we should get 120. Okay, so we've actually got 120. Now we've got a likeness between 400 and 100, so that means we've got 520. And now we can slot the 7,000 in there, 7,520. So your place value is really, really important there. I didn't cross out the 50 just because we need to see it to complete this part. So 50 and the 25, you should know that half of 50 is 25, meaning that we actually need 2 lots of 25s to get us to 50. Then we have 6,005 to get us to 7,000. So if we take 5 off 7,000, what we're going to do, or we could count up, it's up to you. So if we've got that 5 from the 1,000 that we're missing, we actually need 995. Great work. From 400 we've got 250, add the 50 on to get us to 300, then we will need 100 more to get us to that 400, so we actually need 150 there. Thank you for your help. We can then look at the number in our sentence. So we've got 7,520. We know there are 7,000s. We know there are 500s. We know there are 2 10s, but we don't have any ones, so there are 0 ones. Really good to go back to really think about the place value of the number, which might make your job a little bit easier. Your turn now. Think carefully about the parts we have. The smaller parts we have to then help you get to the whole and the missing parts. Pause the screen, give yourself some work now time. Lovely, so we actually have 15,000 here, 850, 70 and 70. Parts of 70 and 70 are alike, so we needed 140 there because we know double 7 is 14. Now we've got 850 and 140 which are alike. We combine those together and we actually end up with 990. We've got 990 and we can put in our 15,000 there. Because we know place value, it slots in lovely, 15,990. I didn't cross out the 70 because we needed to see what the 9 needed. The 9 needs, take 9 from the 70, you're left with 61. 850, we've got 350, which is great because then that just leaves us with 500. So hopefully we should have spotted the relationship between 500 and 300 there. And then if we've got 7,000 from the 15,000, we take 7 off 15, we're actually left with what? What we're left with? We're left with 8,000. Give yourself a lovely tick if you managed to get that. If you made a little error in there, that's completely fine. Go back, have a little check what you spotted. Again, help me out. This side. 4,000, 1,200, 300, 6,000. There's lots of likeness there because we've got a 4,000 and a 6,000, which is actually really nicely 10,000. But then we've actually got a 1,200 in there. So we've got actually 11,200 to get us to where we need to be there. But is that it? Is that our job done? No, we've actually not got our 300 in there because our 200 and our 300 become together as 500. Yeah, so don't get too quick with it. Make sure we're stopping and we're thinking about it. Oh, a bit thick there. So we've got 11,500. Looking at our 6,000, we've already got 3,500. 500 will take us up to the next 1,000, which will be 4,000. We've got 4,000, we need 6,000, we're needing 2 more. With 1,200, we've got flexibility there. We can partition that in many different ways. You choose a way, I'm going to choose a way to make my life easy, and I'm going to go 1,200. And then actually for 4,000, we've got 800 at the minute. 200 will take us to the 1,000, which gives us 1,000, and actually we need 4,000, so I need 3 more thousands for 3,200. So let's look at it in our sentence. We've got 11,500. Lovely. So we've got 11,500. There are 11,000s, there are 500s, there are 0 10s, and there are 0 1s. We are happy with that. Nice round number. Now it's up to you. Pause the screen, give yourself some working out time. Right, so we've got 19,000, 360, 40 and 66, sorry. So we've got 60 and the 40 together will give us 100. So actually we're rounding that up to 400 now. So we've actually got 19,406. 19,406. You can put your comma in there if that does help you with reading those numbers. If we've got 3 of the 19,000 there, that means we've got 16 of them left. We've got 360, we've got 150 of it. 10 more will get us to 60, and then we're actually only missing 200. 210 would get us there. Then our 6, we've got 1.5 of it. Take the 1 off, left with 5, take half it off, 4.5 we have. That's 4.5 plus the other half gives us 5, plus the 1 gives us 6. So great work if you manage to recognise that. So year 5, the difference now, we've got a red cross on our screen, meaning there might be an error involved in our part whole model. Check, see if you think there's an error. If there's not, complete the part whole model. Off you go. Right, we're back in. Did we see if there were any errors? Got to be open-minded at this. There might be an error, there might not be. We've got 14,306. What can we see? 7,000. So we've got the 7,000 and the 7,000, which gives us the 14,000. Great spot. We've got the 6, which is great. And we've got 150. What do we need to 150 to get us to the 300? Is another 150, don't we? And then you can go off and partition these into many different ways. So there actually wasn't an error in there. So great work for keeping that mind open. You might go for 2,000 and 5,000 in there. Might go for 150 in there. And again, you might go for 150 in there. Again, same mindset. Look at this problem. Are there any errors in there? If they are, correct them. If not, you go off and solve the problem. Off you go. Right, what have we spotted? Right, the 300 and the 700 gives us 1,000. The 1,000 and the 1,000 here gives us 2,000s, meaning we need actually another 1,000 more. But we've got 500 there, which marries up, and we've only got 4. We need 2 more. So we actually need 1,000 and 2 more there. So there wasn't an error in there. You could have gone and put an error in there. You can partition this off yourself to 1,500 and maybe 1,002. But as I say, there are many different ways to do that. Okay, well done. So now, you have got 6 part whole models to be working with. Pause the screen, give yourself enough working out time. Please make sure you note the instruction at the bottom of this one. All parts must be equal. So if there are 4 parts, what is that going to be the same as doing? Thinking about those procedures that we've been practicing. Off you go, work on those part whole models. So lovely. What we have, we've got 6,000, 450, 450. That gives us 900. Then we've got 88, so we've actually got 6,988. Nice simple one to get us started. 405, 405, we've actually got a double there. Gives us 810, which is lovely because we can combine that with our 90 to give us 900. And then we've got 34,900. Again, look for those patterns to make your life easy. Oh, we've got part of a number missing here. We've got 1.4 plus a 0.1 gives us the 1.5. So we can see that there. We've got the 3,200 of the 6,400. We've got the other 3,000. So we've got 6,200, so meaning we needed another 200 in there. This down here, 7,502. We can see 5,000, which is great. We can see 2,000, which is also great because then we have our 7,000. We then need 502. But at the moment, we've got 250 plus the 50 gives us 300 plus the 100 gives us 400. So actually at 400, but we need to be at 502. So actually we need 102 more. 64,000 shared equally between 4 is the same as dividing by 4. So actually half and half and again. So half of 64,000 is 32,000 and half of 32,000 is 16,000. So we need 4 lots of 16,000 in our parts there. So they should be equal. Good work if you recognise that relationship quite quickly. And finally, we're missing the whole. 6.4 plus 6.2. 0.4 plus the 2 is going to be 6.6, but we know 6 and 6 is 12. So we've actually got 12.6 there. Then we've got 3,100 and 900. That actually combines together as 4,000. We should hopefully recognise that. So we've got 4,012.6. Great work. Now, second activity, an activity that you know we have worked with many a time. So I'm not going to actually explain anything more. Use the red fact to help you solve the different facts that are already outlined for you. Shouldn't have to be doing formal methods. Look for the relationship connections to see the impact on the other side of the calculation. Pause the screen, get some work out done. Right. What we can see, the difference being that 9 is actually 10 times more, meaning that the impact of the answer is going to be 10 times more, which is 270. 90 and 30, both 10 times more, and we know that 10 times is 100 times, meaning that the 27 will increase by 100 times. The 900 times by the 3, actually the calculation is again increased by 100 times, so we've got the same result as prior. This time, we're times them by a multiple of 10 times less, meaning that our 27 will actually be the value of 10 times less, which will be 2.7. Then we've got 27 divided by 3, just the inverse there. We can go and find 9 there. Then we can use this fact to help us with others. If we've got 270 divided by 3, we're actually going to be left with a multiple of 10 value more. Still divided by 3, but our whole there was of 10 times value more, meaning our other part is 10 times value more. We're now 100 times value more, but we're dividing by 10 times value more, meaning that we're left with a number with a value of 10 times value more. Then we've got 27 divided by 0.3, which is 10 times value less. So we've got a whole, and we're dividing into really, really small parts. We're going to end up with even more parts. So we're not just left with the 9 parts, we're actually left with the 10 times value more rather than the 10 times value less to balance it out, because we know that this equal sign means that we need to have a balance on both sides, and we need to see what the impact is on one side to balance it out with the other. Same again with this activity. Use the red calculation to help you solve the other relationships that we have. Pause the screen, give yourself some work now time. Right, so as we can see, 10 times value more, meaning that the other part of our calculation is 10 times value more. 10 times and 10 times is 100 times, meaning an impact of 100 times on this side. We've actually got 100 times and 10 times here. 100 times 10 is 1,000 times, so the impact is actually 1,000 times more, meaning we have the 3 zeros in there. Here, we've got 10 times less, meaning our result will be 10 times less, meaning we've got a decimal there of 6.3. 63 divided by 7, simple, inverse again, divided by 9 would give us the 7, so divided by 7 would give us the 9. Then we've got a value of 10 times more, but we've divided by 10 times more, meaning that that balances out and we're still left, oh, not with the 3, that is my problem, I was thinking of the last calculation. Then we have 9 there. Then we've got 6,300, 100 times more, divided by a value of 10 times more, balances to give us a value of 10 times more left over. Then 63 again, it's been divided by a really small number because it's 10 times less, meaning that the impact is going to have a 10 times more impact on the other part that is left. Okay, so again, those equal signs are really important to balance us out. Finish us off with a calculation that I have given you, but I want you to choose the relationship statements that you know because of this fact. Off you go. So you could have lots of different calculations here. You might have got inverse straight off and included the divide sign in there. You might have gone straight from multiple moles of 10. Ten times more, 10 times more, 100 times more, 100 times impact. You might have gone less by dividing it by 10. There are many different relationships that you can have. Check your calculations on a calculator or get an adult to check for you. Again, this one's a little bit different, not the normal one that you would see in your times table chart. Okay, so look at the calculation, 6 times 0.6 equals 3.6. Spend some time recognising the facts that you know because of this. Should be at least 5. Pause the screen, off you go. Right, this is the amazing thing about this relationship knowledge. Not normally a times table fact that we would pull out, but we know it, we're comfortable with it. So as we know that, we also know that 0.6 times 6 is equal to 3.6. We also know that 3.6 divided by 6 is equal to 0.6. But we also know that 3.6 divided by 0.6 is going to leave us with 6. We know that. Who would have thought we'd be working with such small numbers so fluently because of that knowledge? Then we can go to the 6 times 6 equaling 36, which we're really comfortable with, and we can play around with it even more. But these facts, get it to a familiar fact that you're more comfortable with and then play around with it. That's what about mathematics is. It's about relationships and making our life a little bit easier. Our third and final activity for today, so keep with me year 5, you're doing really, really well, is rounding. Rounding is an activity I know you're super good at, but let's be careful that we are rounding to the nearest multiple correctly. To be good at rounding, you need to be good at counting in multiples and recognising those multiples in the larger number that we see. So we're going to be working with the nearest multiple of 100 to start us off with, but which current 100 are we at? We're actually at 64,600. It's 64,600. So before that, we would have had 64,500, 64,600, and our next 100 will be 64,700. Great. What is the midpoint between 600 and 700? It's actually 650. So we've actually got 64,650, but we're not quite at that point because we're only at 640. So meaning we would need to round down, because anything on this side of the number line needs to go down. Anything from the midpoint onwards, we need to round up. So when rounding 64,645 to the nearest multiple of 100, remember we could round this number to many different multiples. We round down to 64,600 because we're closer to it. Get to the closest multiple. Now, pause the screen, round to the nearest multiple of 100, off you go. Right, we are currently at 72,700. Before that, we would have been at 72,600, 72,700, now 72,800 could be a possibility. The midpoint between 700 and 800 would be 750, but actually we're not quite at 50, we're only at 30, meaning we need to round down, don't we? Fantastic. Again, we're off, rounding to the nearest multiple of 1,000. This is the last one I'm going to model, and then the rest are up to you. Multiple of 1,000, we are currently at 67,000. What would our next multiple be? We're at 66,000, then 67,000, now 68,000. Between 67,000 and 68,000, our midpoint would be 67,500. But are we at 500? We're currently not at 500, we're only at 400, meaning we round down. So when rounding 67,475 to the nearest multiple of 1,000, we round down to 67,000. Great work. You're up. Round to the nearest multiple of 1,000. Pause the screen, give yourself some working out time. Right, we are currently at 71,000. Before that, we'll have been at 70,000. Then we're at 71. Then we would be at 72,000. That's what I mean by counting in multiples. Your midpoint would be 71,500. But are we at 500? No, we're actually at 700, meaning we're past the midpoint, meaning we need to round up to 72,000. So give yourself a nice little tick if you manage to recognise that. Now, nearest multiple of 1,000 again. See where we're at, see where we could be, choose whether you need to round up or down. Pause the screen, off you go. Right, so where are we currently at with nearest multiple of 1,000? We're currently at 35,000. Beforehand we would have been at 34,000, 35,000, now we would move to 36,000. Our midpoint would be 35,500. Are we at there? Yes, we're actually 516, meaning we're just a little bit past it, meaning we would need to round up to 36,000. Nearest multiple of 1,000 again. Pause the screen, give yourself some working out time and solve the problem. Off you go. Right, nearest multiple of 1,000, we are currently at, get my pen, 91,000. Our next multiple would be 92,000. Our midpoint would be 91,500. Where are we at? Yes, we're at 500, 570 actually, so a little bit further along. And we would round up to 92,000 because we're closest to it. Anything from the midpoint onwards, we round up to that closest multiple. Again, something you really practiced at. That's what I want you to do, is to keep practicing those skills that you are comfortable with, to keep that confidence nice and high. We've got 3 numbers here. I would like you to round each of those numbers to the nearest multiple of 10, nearest multiple of 100, and also nearest multiple of 1,000 as well. Okay, so all 3 numbers to each of those multiples, Pause the screen, give yourself some working out time before I reveal the answers. Off you go. And we're back. And as you can see, we've represented the answers here. Nearest multiple of 10 for 2,242 was either 40 or 50, and we got 240 because 2 is closest to 40. Closest to 200 or 300, the 40 tells us we're actually closest to 200. And then 2,200, the 200 tells us we're closest to 2,000 rather than 3,000. With a 7,064 multiple of 10, we're the closest to 60, which we're currently at, or 70. The 4 tells us we're closest to 60. Multiple of 100, we're either closest to 7,000 on the dot, or with 7,100. But the 60 told us we are closest to 100. With the thousands, we were either closest to 7,000 or 8,000. 0 hundreds tells us we're way closer to 7,000. Then finally, 15,201. The multiples of 10 we're working with is either just 15,200 with no 10s there, or with one 10 with 15,210. However, with only having one, we know we're closest to 200. Then round to the next 100, 15,201 or 300, 201, no 10s again, tells us we're really close to 200. And then from 15,000 to 16,000, the 200, the low number of 2, tells us we round down to 15,000. That is it for your math skills lesson today, year 5. Not a lot of me talking, more of you working. So well done today. 3 activities done and dusted. Keep practicing those math skills at home. Thank you.